Hello, my name is Eric, and this is my Lab 5 Make Your Adventure. So, to begin, these are some fundamental principles from our lab. We have Newton's second law, where F is equal to ma. We are using position and update formulas. And in this lab, we're primarily looking at the conservation of kinetic energy, which is tied to momentum, which is, 1 half mv initial squared equals 1 half mv velocity final squared. So, the purpose of my lab was to record the trajectory of two billiard balls in the x and y direction. And in doing so, we just compared the experimental data to the computer simulation. And ultimately, we're seeing if kinetic energy is conserved within this experiment. And here are some assumptions. We're assuming the system is the two billiard balls. The surroundings is everything else. And we're also disregarding the force or impulse of the stick because that's a lot more complicated. So here was the tracker analysis I had. As you can see, the two billiard balls collide. Alright, so ball 1 is x component. So initially the ball, it goes in a negative x direction, but once it collides, its x velocity goes to the right, but it's noticeably slower. And for its y component, it's similar to x, except in regards to its velocity, it just loses a lot more. And if for ball 2, the x component, well, ball 2 obviously is stationary, so it starts at 0. But once the collision happens, the x velocity is pointed to the left. And then for the y component, it gains a lot of y velocity in the negative direction once it's hit. And also for the video, the increments is in, well, the video is based on 60 frames per second. So here are the initial conditions. For the masses of the balls, I just searched up the mass of the average mass of a billiard ball, which ended up being 0.17 kilograms. And for the velocity of ball 1, I took the next increment of once it moved. So I took the distance equal to velocity time equation and rearranged it, and then I looked at the values and I ended up with those. And for ball 2, obviously the velocity is 0. And here's the iterations. So we have the position update formulas, and we have the curves. And also at the bottom I had a detection. So once the collision was detected, the velocity of the x and y were changed. And this is also based off the experiment, where I looked at the increments and was able to find these values. And here were the results. So on the left we have the coded one, or not my bad. On the left we have the tracker, and on the right we have the coded. And as you can see, the position of them appear very similar. And this is proven by the position graphs of ball 1, which the top is the x, the bottom is the y. Similarly here, ball 2, top is x, position is y. And ultimately, we're determining the kinetic energy and whether it's conserved or not. So the initial kinetic energy is 1 half mv of ball 1 squared, because ball 2 has no velocity, so it cancels out. And the final would be 1 half mv of ball 1 squared plus 1 half m of v2 squared. And ultimately, that's the work demonstrated right there. And for the initial kinetic energy, I got the value to be 1.6387 joules, and the final kinetic energy to be 1.2835 joules. So the verdict: no, kinetic energy is not conserved. Boo-hoo. And here's just a little short discussion. What type of collision was this whole lab? Which, based off the data, this is an inelastic collision, which means kinetic energy is not conserved. However, the billiard ball example is typically used when professors or anyone says elastic collisions, because in real life, they're the closest thing you could get to where momentum and kinetic energy is conserved. But ultimately, in real life, most systems, kinetic energy is not conserved, as it's lost to sound or, friction, which that leads me to point 2. What type of errors may have caused the data? Obviously, there's some human error because, tracker putting the point of mass. Similarly, I didn't account for friction, which could ultimately lead to kinetic energy being not conserved. And also, like I said, I ignored the force of the stick, which would be the impulse, which probably had a part in this. But yeah, thank you.